Alright, so while wiring up the trackballs for use on the Atari football boards I've been repairing, I inadvertently swapped the positive 5 in the ground terminals going to the trackball, which knocked out both of the optical interrupter boards. So I've removed the optical interrupter assemblies, and I'm going to try to repair these. I bought some parts off of AliExpress. The part number is PT928-6C-F. It's a 940 nanometer wavelength photo transistors. I'm assuming the diodes survive, because if you reverse the voltage on the diodes, the current doesn't flow. They only emit light when it's forward biased. So I'm assuming those are going to be okay, and I'm just replacing the photo transistors. So I'm going to have to pry them out of these assemblies and put them back in. We'll see how that goes. I've done this before, though. I've been able to do it, but sometimes these housings get damaged, and but might still be usable. I'll take care there. While I have these out, I'll reflow the solder joints on these connectors. They tend to develop cracks. If you look at the back of these boards, the two top holes in this picture here are going to be the diodes. You can see by the symbols there, and these are going to be the photo transistors as indicated by the E, which means emitter. These are emitter-based collector NPN type photo transistors. So I will replace these, and I'll get back with you. By the way, when you zap them, the output signals from these are always high, and they don't toggle ever. Alright, so I'm halfway through on this first one. One of them's been removed. Just stopping short of removing this one so I can show you how to do it. You take a pointy thing like this, an ice pick type thing, and you scrape away the back side of this, okay? You're not going to be able to get it out without removing it. And then once you get to this point, then you take that pointy thing and you push it in there and you pry down and push it out. Once you get it moving, then you can use pliers or something to grab the legs and pull it the rest of the way out. But these are a pain. It destroys the back sides, but that's okay. It'll still work. If you're worried about it, you can put a piece of black tape or something. But yeah, I mean, it destroys the housing, but I'm just going for functionality. I don't care what it looks like, because you're not going to see it anyway, right? Okay, so I've got the old devices out of the first housing, and I'm laying the new part and the old part side by side, and you can see they're very similar in size, but the new part is slightly fatter to where it didn't want to slide in easily. So I'm going to take a Dremel tool and grind down the sides a little bit so it'll slide into the housing easier. Also, there's a little intrusion on the front that may interfere with things. If it does, I'll clip that off with some clippers. So, or grind it off with the Dremel tool. Either way, it looks like some mods are going to be needed for these devices, but it looks like it's going to be minor. They're close already, so let me continue. Okay, since these aren't an exact replacement for the devices I'm replacing, there's a lot of grinding needing to be done. It doesn't look like much, but it really takes quite a bit. I'm finding that I'm grinding a lot off the backside and quite a bit off the sides. And you also have to remove the front protrusion there. See how it sticks out at the bottom? So that has to be clipped off and then ground off a little bit if you can. I was able to use just clippers here. The thing is, if you scratch up the surface where the light emits from, see that little dot there? If you scratch that up, it's going to cause it to not work well. So if you do that, like I did on this one, let's see if I can get the focus. I scratched it up just a little bit, so I'm not going to use this one. It may still work, I don't know. But you can see what I did. I'm grinding off the back side and that little protrusion on the front and the edges on each side of so that it will fit in like so. So a lot of grinding. I'm using this type of Dremel tool here. I'm using a diamond tip needle thing so I can accurately control how I'm shaving off the plastic. So let me continue, but I got the first one in. It slides in tight, which is good. You don't want to move around. So I guess you could overdo it, but I don't see how. If you overdo it, you probably damage the device. All right, continuing. All right, now that I have two of them installed in one of the devices, I'm going to go ahead and put this back on the optical interrupter board. and install on Trackball and see if it's working. I use a scope to see if it pulses or not. If not, then the device is not compatible with the diodes, or the light emitting diodes themselves are bad. So I think I can use my camera to video record the light emitting diodes. So if they're light emitting, then these might not be the right frequency. These are 940 nanometer wavelength devices. I don't know what the original diodes were. I chose 940 because that's a very popular wavelength to use. So anyway, next step is to install it back on one of these circuit boards here and give it a test. Well, I tested this and it still doesn't work. So the diodes are bad or not matched with the 940 nanometer photo transistors that I installed. The other unit has a slightly different design. This one you can see has like a clip design that clips them in, but they're still kind of glued in or something. They're difficult to get out. This one, these are enclosed in. I already removed one, and what you have to do is you have to grind out a slot so that you can get in there and push down on it really hard to break it loose from the glue that's in there. So I did one side of this one to test it to see if the diodes would if it would work just on the one half, and it doesn't. So again, the diodes are either dead or not matched for the photo transistor. So on this particular device, you can see I'm going to have to on both sides, both the diodes and transistors, I'm going to grind a slot all the way down to get these things out of there and be able to reuse the housing. So you can see I did it on this one. This is a new photo transistor. So I've got the photo diodes on order, the light emitting diodes on order. Their infrared frequency of 940 to match these guys. So once I replace those, I'm expecting these to work. Well, that's it for now until I get the parts in. So this will probably just be continued on this video. So the part numbers for the two devices that I'm replacing the components in. The enclosed one is SPX5129-1. The older model is an OPB2208-1. The one on the left was made in 1983. The one on the right was made in 1982. I presume by the same company, not sure. Again, SPX5129-1 and OPB2208-1. Okay, so it's the next day, and as it turns out, I got the photo diodes in the mail today. There's the part number, IR928-6C-F. That is the matched pair for the photo transistors that I talked about earlier. So these have the same packaging as the previous guys. So I'm going to have to do the Dremel thing and trim down the sides and the back to get it to fit in there, and also clip off the front appendage. So let me do those, get these installed, and then we will test and see if it works. Got a feeling it will. Okay, so I've got the photo transistors, the new photo transistors and the new photo diodes installed onto one of the assemblies, and I plugged it into my trackball. Let me see if I can show you on the scope. It is working. So this is one of the, well, this is going to be fun. Oh, how am I going to do this? Let's see. Oh, I wish I had somebody here holding the camera. That'd make it a lot easier. All right. There it is. Well. Okay, so it should be high when it's not blocked. I can get the probe to stay. All right, it's high when it's not blocked, and I'm blocking it. Oh, my probe slipped. So I'm blocking it and unblocking it. So the signal's there. So that got it. Either the diodes were bad, or they weren't matched. I suspect they weren't matched, because I think the old diodes worked still. Anyway, so that was kind of hard to demonstrate, but it does show it works. So let me put this together. I'll put the other one together, which you can see I haven't touched yet. I'll grind down 2 more of those diodes and install them in this guy, and then I'll put it in the trackball and we'll test it on a game or something. Got the second assembly installed, the photo diodes and photo transistors installed, and got my trackball plugged in to this missile command board that's broken that I'll be working on next. And as you can see, maybe you can't, the trackball's working. The one of the rollers doesn't want to roll well, but you can tell it's registering, so fixed. A lot of people have these types of optical interrupters on these old trackballs, and they have probably a drawer full of them that they can't repair because you can't get the parts. Well, you can get parts that you can force into the application and get it to work, as I've shown here. So, hope this video helps somebody.